Today, we'll demonstrate a production-ready agent-to-agent framework built on Azure Foundry. This framework is not a single technology, but a composition of integrated services that together establish an open, secure, intelligent, and interoperable ecosystem. It enables agents to scale seamlessly across organizational boundaries while collaborating effectively with humans. Within this framework, we leverage open communication protocols, a discovery and registry service, identity and trust management, tool invocation and integration, orchestration, multimodal document processing, telemetry and observability, memory, evaluation, and governance. Because the framework is domain agnostic, it isn't limited to a single workflow or industry. The agents connected to the system ultimately define the scenarios it can support, meaning organizations can design their own personalized multi-agent ecosystems. To bring this to life, let's walk through a specific scenario. We'll follow Julia, a claim specialist, as she processes a customer claim for Simon, showing how humans and agents can collaborate in real time to deliver faster, smarter outcomes. Julia begins by logging into the system, where her profile card highlights her role, skills, and active session. Other human specialists can also join, logging in to collaborate with Julia, demonstrating how humans and agents operate side by side within the same environment. Users connected to the system can interact with Julia directly, whether through instant messages or real-time calls, creating a fluid channel for teamwork. As an administrator, Julia has the ability to extend this collaboration beyond humans. She can seamlessly connect and register any A2A compliant remote agent into her session, simply by providing its endpoint or IP address. These agents can be deployed anywhere, across different clouds, within on-premises environments, or built on diverse agent technologies. This interoperability highlights the power of the framework, enabling Julia to dynamically assemble the right mix of human expertise and autonomous agents to solve complex problems without being constrained by deployment boundaries or vendor lock-in. Julia also has access to a central repository of pre-registered agents that can be connected to the system on demand. Every time a new agent registers, it is automatically added to the shared agent catalog, making it available for future use by anyone with the appropriate permissions. Within this catalog, Julia can see a diverse set of specialized agents ready to assist. For example, she can leverage a classification agent powered by Azure Foundry, designed to handle triage tasks. This agent is grounded in company knowledge, capable of searching the web, and can provide intelligent routing and categorization of requests. She also has access to a sentiment analysis agent, a specialized Google ADK-powered agent, which can analyze sentiment in real time and adapt conversations to improve customer experience. Beyond these, the catalog includes powerful domain-specific agents, a claims specialist agent capable of analyzing and processing claims, validating coverage, calculating settlements, and guiding resolution, an assessment and estimation agent designed to evaluate damages and provide accurate cost estimates, a fraud intelligence agent equipped to detect anomalies, flag potential fraud, organize evidence, and provide risk assessments. For this particular scenario, Julia decides to connect the claims specialist agent, the assessment and estimation agent, and the fraud intelligence agent, building a collaborative team of specialized agents to help her process Simon's claim efficiently and accurately. On the screen, we can now see each of the connected agents along with their agent cards, displaying their status and specialized skills. Julia has already gathered all the key materials for Simon's claim, a video showing the car damage, a PDF of his auto insurance policy, with vehicle details, coverage, policy period, and claim history, a Word document containing the official police collision report, and an image of Simon's driver's license. Thanks to Azure Content Understanding, the host orchestration framework can process and interpret this wide variety of multimodal content, videos, images, Word and Excel documents, and over 250 other file types. Julia can simply drag and drop these files into the system, where they are automatically ingested, analyzed, and added into a centralized memory layer. This memory is not static, it's dynamic and shared. Remote agents have access not only to the conversation history, but also to the structured knowledge extracted from these documents. More importantly, agents can share relevant insights with each other, creating a distributed memory fabric that ensures every agent is contextually aware of what's happening in the session. This is where the true power of memory comes in. It allows the system to operate as a collective intelligence, rather than isolated components. With Simon's claim data attached and enriched through this memory layer, Julia is now ready to kick off the multi-agent orchestration, seamlessly bringing together human expertise and specialized agents to process the claim. The host orchestrator takes the first step by processing Simon's documents, the car damage video, the insurance policy, the driver's license, and the police report, and storing them in the shared memory. With the data prepared, the three connected agents are each assigned A2A tasks, which they begin executing in parallel. To make this process transparent, the system uses a thinking box, a detailed execution thread that shows every step unfolding in real time, which agents are being called, the function calls sent to remote agents, and the outputs they return. On the right, we can see each agent actively working on its assigned task, with their A2A states updating live. At one point, one of the agents encounters a rate limit failure. Instead of halting progress, this showcases the framework's robust retry mechanism, allowing agents to automatically handle their own errors. In this case, the agent retries until successful, ensuring no task is left incomplete. Once all agents have finished their work, the host orchestrator consolidates their outputs and replies with a complete summary of everything accomplished, demonstrating a seamless, resilient, and fully observable multi-agent workflow. In this run, we can see the value of each agent clearly. The claims agent validated Simon's insurance coverage against the policy terms. The assessment and estimation agent generated a detailed cost breakdown using the video evidence and the police collision report. Meanwhile, the fraud intelligence agent flagged critical discrepancies. The front-end damage captured in the video was inconsistent with the rear-end collision described in the police report, and the timing of the claim, filed just before policy expiration, raised additional fraud indicators. All of these findings are compiled into clear recommendations and next steps, presented directly to Julia, empowering her to make an informed decision. With that, the claim workflow is complete and the demo comes to a close. As we transition to the next demonstration, we'll explore a completely different use case powered by the same framework. What you'll notice is that the system itself remains constant. What changes are the humans and agents we connect to it. Together, they define the true scope of what this ecosystem can achieve.